It is given that two spherical bodies of mass m and 5m and radii r and 2r are released in space with the initial separation between their centers is equal to 12r. If they attract each other due to gravitational force, then the distance covered by the smaller body before collision is. So this question is basically related to center of mass or conservation of momentum. So just try to understand this question. Two spherical bodies of mass m and 5m. One spherical body, we can just consider that mass is equal to m, and another spherical body is bigger than this, and its mass we can take it as nothing but 5m. And this one is having a radius that is equal to r, and this one is having a radius that is equal to 2r. Are released in space with initial separation between their centers is equal to 12r. So the distance between their center is given as nothing but 12r. Now we know that due to gravitational force, like this m is going to attract 5m with the force F, and 5m is going to attract m with the same force. So they are going to exert equal forces on each other, so that net force acting on the system or net external force acting on the system is equal to 0. If you are taking these two as a system, then the net force is equal to 0, then or the net external force is equal to 0. If net external force is equal to 0, then we can say that the displacement of center of mass will be equal to 0, because when net force is equal to 0, when net external force is equal to 0, acceleration of center of mass of system will be equal to 0, velocity of center of mass is equal to 0, and displacement of center of mass will be equal to 0. Now we can find out the end question. They are asking to find out the distance covered by the smaller body before collision. So we can just consider that this smaller body is moving towards the larger body, and after some times this smaller body is going to make a collision with this, and larger body is also coming towards smaller body. Assume that it's traveled some distance, and same as like this heavy object is also traveling some distance towards this, and they made a collision over here. So initially the center of mass of this was somewhere over here on this position. Now it is displaced to this position. Let's say this displaced by a distance is equal to nothing but x, and this is equal to the this distance, which we can take it as the radius of first one. This distance is the radius of second one, which we can take it as 2r, and this was representing the initial position of heavy object. Now it is displaced towards left by some distance, let's say this much distance, and according to the question, this distance is given as something but 12r. So this distance is 12r. So we can find out what about this distance. This is x, this is r, this is 2r. So the total distance from here to here is nothing but 3r plus x. So distance from here to here is 12r minus 3r plus x. So distance from here to here can be written as 12r minus 3r plus x. So 12r minus 3r, which we can take it as 9r minus x. So this distance can be written as nothing but 9r minus x. Now we can observe that, or we assume that the smaller object is displaced towards right by some distance, let's say s1, and the heavy object is displaced towards left by some displacement, take it as s2. Now we can use the concept that displacement of center of mass is equal to 0, and we all know the equation for displacement of center of mass is m1 s1 plus m2 s2 divided by m1 plus m2. This should be equal to 0. That means m1 s1 vector plus m2 s2 vector should be equal to 0. That means m1 s1 should be equal to nothing but minus of m2 s2. Now this displacement is a vector quantity, and Rm is to find out the displacement of small object. So mass of small object, we are taking it as m, and its displacement Rm is to find out. I'm just taking it as s1 vector is equal to mass of second object is given as something but 5m, and displacement of second object is this get displaced towards left. So we can take it as negative value minus of 9r minus x. So this negative and this negative is going to be positive. So we can write the displacement is equal to this m and this m get cancelled. So we can write this is equal to nothing but a a displacement of this object, which we assume that its displacement is equal to nothing but x. So we can write this S1 as nothing but x is equal to 5 into 9r minus x. This m and this m are basically same, they will get cancelled, and this negative and negative, it's going to be positive. So we can find out the value of x over here. That is 45r minus 5x, or you can write the 6x is equal to 45r, or you can write x is equal to 45r divided by 45r divided by 6, which is equal to 7.5r.